It's been a while since we looked at a faulty Commodore 64, and today we have one such machine on the bench, this rather dirty looking C64C. Thing is though, I'm not 100% sure if this machine is truly faulty or perhaps it's just haunted. And that's because the problem with this machine is that it's showing random numbers on the screen. So other than the possibility that it's trying to tell me the winning lottery numbers, there's something wrong in here. So let's see if we can't fix that. Power LED doesn't seem to work either. And that's interesting as well, isn't it? Look at that image on the screen. Now most of the text is blue, which is correct, but there are some characters there that are flickering white. Let's just power cycle. So we've seen garbage there for a second. And again, the text on the screen is mostly blue. Some of it is white. So initially I was thinking that this might just be a faulty CIA. But given the color corruption, could it be something different? Could it be the color RAM? If this machine even has a separate color RAM chip, that is, because it could be built into the PLA. Could it be a fault with that then? Could it be a fault with the PLA? Only one way to find out. Let's get it apart. So just 3 screws on these, missing feet as well. Just 3 screws along the front, and it's just clips at the back. Crusty. I did not want to come apart there, but there's a little retaining clip on the side as well. You sort of need to push the side of the case in to get that apart. Keyboard then has 2 screws holding that in. The old cardboard shielding, we will be discarding that. And yes, this machine does have separate color RAM chips, so if there is a fault in there causing those flickering colors on the screen, at least we can swap that out. It's not integrated into the PLA. Now granted, it's very unlikely that fault in there would be causing any problems with the keyboard, so possibly there are 2 faults on this machine. It is incredibly dirty though, so let me continue stripping this down. There's 2 more screws to remove there and there on these brackets that hold the keyboard, and then just a couple of screws holding the motherboard itself in place. Let's pull the board out. I'm going to give it a bit of a dust. We'll inspect the back of it, and you never know, maybe just cleaning it would be enough to fix some of those problems. Just go over it lightly with the toothbrush. Try to remove the worst of the dust. There's a spot of corrosion on the board there. Need to take a closer look at that. The underside of the board though is in really good condition, and I certainly don't see any signs of any rework. There's a scratch there. Yeah, whatever that is, that has certainly went through the solder mask, because I can see copper there. And that is one of the CIAs. Although that is the CIA that's dealing with the keyboard. There's a slightly better look at that wee bit of corrosion. I do think it is just superficial, but let's just try a bit of IPA on this cotton bud. But certainly from a visual inspection anyway, that looks fine. So you can just about see the scratch there. Hopefully you can make it out. It is quite deep. It has taken the coating off those traces. I can see copper there, but has it broke them? Let me just try and buzz these out. And it runs across this one here as well, albeit they've all been fine so far. Yeah, that's okay. Let's just give it another quick test just to confirm the problem, now that we've given it a bit of a cleaning up. And I suppose actually, since the keyboard's disconnected and it's still doing that, that sort of confirms that the keyboard itself is not the problem. There's a big lump of dirt on the keyboard connector. Could it be as simple as that? Nope. I think it's about time we broke out the diagnostic harness. Let's hook this up and see what it says. We're just going to run this in the C64 diagnostic mode. No point in doing dead test because, well, the system does work to some extent anyway. And we may as well just hook everything up and go for the full test. So what are we expecting to see? Well, I'm thinking that the color RAM is going to come back as bad, and we're going to see at least one bad CIA. What just happened? Has my dead test card died? Or, well, my multi-test cart, should I say. This thing can do multiple different tests. So is this one here we're trying to run A15 low, yep. A14 low, yep. A13 low, yes. ROM should be on low, and it is. Game should be open, which it is. And EXROM should be closed, which it is. Why is this not working? Just to make sure I'm not going mad, I pulled out this other board, which I know is good. And we can try the cartridge in that. Yeah. So that works. And I know this machine is fine, so we don't need to run that right through. But in this one, nothing. The machine just boots as usual. Notice that the keyboard thing is away. Let me hook up the keyboard. Aha, there's no cursor either. System has crashed. Let me take this back out. And the keyboard problem reappears. You can see there that if I do type, and if I just keep hitting G, you can see G's appear. All the numbers that randomly appear are just this top row. There is a few characters there. You can see a pound sign and plus, but it's all just top row stuff. Let's just try this in its dead test mode. I have it set there. Just want to see what it's going to do like that. Black screen. Dead test can sit on a black screen for a few seconds. But certainly by now, I would have expected it to show up. If you have a RAM fault on the machine, what you would expect is that dead test would sit at a black screen but flash the screen. And it's just doing nothing here. Although there is nothing to suggest that we do have a RAM fault. Because if we take that back out, the system has counted up its 38,911 basic bytes free, which is correct. So that one has definitely thrown me. What is going on with this board? Why will it not boot to a cartridge? Right, there's two problems with this board. We can only deal with them one at a time. So let's start with the keyboard. I don't think the two problems are related. I suppose they might be. It could possibly be the kernel, you know, as that would be the only component in here that, you know, speaks to both the cartridge port and the keyboard, but I'm not convinced. I think the fault with the keyboard is more likely to be the CIA, because these things feel for fun. Now the problem that we're seeing is that these characters on the top row are randomly appearing, or well, some of them are anyway. Because if we take a look at the C64's keyboard matrix, well, you can see 13579 plus £. Well, those are the characters that were appearing on the screen, and that is all row 0. Now if we go over to the schematic, we can see that row 0 is on pin 12 of the keyboard connector. And the way that I understand this keyboard works anyway, I could be wrong, but the way that I understand it is that each of the pins on the rows, that's held high. When you press a key on the keyboard, you are pulling that entire row low. The kernel then, well, it is scanning the column pins 60 times a second, and where it detects the corresponding column being pulled low with the corresponding row, well, that's your keystroke. So if we power this thing on and take a look with the scope, what I'm sort of expecting to see here on pin 12 or row 0 is that it is being held low constantly. So 1, 2 is blanked, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And yes, it is. That is being held low. There's that clock there that I was talking about. And you can see that the frequency of it is, well, more or less 60 Hertz. So that is the kernel trying to read the keyboard 60 times a second. So you can see, as per the schematic, the only thing talking to these pins is really the CIA. So that leads me to believe that that chip is faulty. It's a shame it's not in a socket on this board. In fact, very little of this board is socketed, isn't it? But what I want to do is pull that, and we can always test it in that other C64C motherboard, because one of its CIAs here is in a socket. We can pop that out, stick that one in there, and run the test. I do wonder though, could it be the kernel, you know? Because the kernel is responsible as well for mapping the ROM. Or at least, I think it is. You see, when the ROM's inserted, there's these two pins here, game and EX ROM. Depending on the type of ROM used, either of those pins would be pulled low via the PLA, which in turn lets the machine know that there's a cartridge installed, and the kernel points to the cartridge to boot it. Right, that's out, and I have fitted a socket in its place. If we power the machine on now, well, I would expect that it will boot the BASIC, and our random numbers on the screen, well, they'll be gone. Just out of interest, if we try the cartridge again, and I've changed this over to the diagnostic mode, yeah, it boots into BASIC and then crashes straight away. I didn't think that would magically fix our problem there, but it was worth testing. Notice there, by the way, that when it does that, the amount of available RAM displayed is less. It's only 30,719. Is that consistent? Yep. Whereas with that removed, it is displaying the correct amount. And that would sort of make sense, wouldn't it? Because as far as I know anyway, that diagnostic card, the ROM for it is 8K, and that figure displayed earlier is 38,911 less 8K. But anyway, I want to test this. So let's get this other board. I'll take this CIA out. Now granted, That's the other one. It's not one controlling the keyboard, but in that position it will be controlling the ports. So we will put these on. Then if we power this up and run this test, well, it will show us if indeed there is a problem on the CIA. And you know what? I do not think there is. Because you see those 2 times down the bottom right corner? If there was a fault in one of the CIAs, it would manifest there. But we'll let it run through the whole test just to be sure. And there you are. That passed with no problems whatsoever. So there is nothing wrong with that chip. Will it be that ROM? That's the ROM there. I took it off the other board, stuck it into the good board, and we're just running the diagnostic test again. And no, it's not that. What is wrong with this board? This would be an awful lot easier, you know, if we could get the cartridge to boot. Maybe we should just put that keyboard fault to the side for now and try to concentrate on getting the cartridge working. I mean, why is that not working? Why is dead test leaving us on a black screen? Has to be something is interfering with the bus. I've tested the VIC and I've tested the SID. Those are good. I tested that U20 just because, you know, it is socketed on both machines anyway. Nothing wrong with that. We know that CIA is good. We now know that kernel basic ROM is good. It doesn't leave an awful lot else to test, really, does it? I mean, if dead test isn't running, it's either going to be a fault in that CIA, the CPU, or the PLA. You know, I'm starting to think that our PLA here might be the problem. I don't want to just pull chips for the sake of it. Suppose I could test all this logic first though, couldn't I? Yeah, I think I'll do that first, just in case. Well, I've been over all of this logic and it's all behaving as you would expect. So seemingly nothing wrong there. I really don't think there's much left other than pulling chips. You know, one place that I do think we have a fault is the colour RAM. And that's because the colours on screen are a bit screwed up, as you can see. But in some ways, if we pulled that out and tested that on the other board, and if that turned out to be good, well, the only other thing that could cause that sort of flashing on the screen is going to be this. It's going to be the PLA. I'm not convinced there's a problem in the CPU because, you know, the system is running over there. Equally, I'm not convinced there's a problem in the character ROM because we are getting characters on the screen and they look correct. And I don't think the problem is going to be caused by this because that is currently isolated on the bus. Chip select is high, it's active low. So that thing isn't connected to the bus at the minute, so that can't be causing any problems. Let's remove that. Colour RAM swapped out for a socket. That is the colour RAM of the good board. Let's see if this solves the issue with the flashing characters. And yes, it seems as if that has fixed that. This other colour RAM that originally came out of this board, well, that one must be bad. At least we fixed something today. Let's just put this in here. Now we can boot to the diagnostic harness, which will check the colour RAM. Yeah, as you can see, that is quite obviously bad. In fact, this system is going crazy now. It is reporting an awful lot of bad chips. That's just from swapping that in. Just want to test this one on dead test. And yeah, as we expected, colour RAM bad. Interesting though that it completely screwed up the diagnostic test. It just crashed that test when it got to that bad RAM. Well, it's a new day, but last night after working on this thing, I was having a bit of a think. Maybe I'm chasing a fault in one of these ICs, when in reality, there's nothing wrong with any of them. Yes, okay, that colour RAM was bad, but maybe there's nothing wrong with the rest of it. Maybe the fault lies on the board itself. Maybe it's a mechanical defect rather than an electrical one. So I've got the idiot goggles on because I've been going over the board looking for dry solder joints. Didn't find any of those, although I did go to the trouble of reflowing several of the other components, even that cartridge port, and it made absolutely no difference. But what was the very first thing that we looked at? That bit of corrosion. You're not going to believe what I've found. Well, this is very familiar, isn't it? We're back at this position, although you can see now that I have exposed all the copper. I just went over those traces with the fiberglass pen. And apologies for the slightly blurry image. I do have the camera on macro, but to blow this up as large as possible, it's currently looking through a magnifying glass. So if we take, say, that one for example, and here that we have continuity the whole way along there where the copper is exposed. But if we go on to this one here below it, continuity, and it's gone. Bring that back up, and there's it back. So we do indeed have a break in that trace. That trace which just so happens to be carrying data line 0 over to the CAA, but also it runs up to that cartridge port. So fingers crossed that is the fault. I'm going to put a little bit of very fine wire just over the top of that trace, solder it in place, and then we'll coat all of that area there, just where the copper is exposed, with a bit of nail polish. So I'm going to use this very fine solid core wire. It's going to expose a section of it there. It's really easy just to break the sheath on this. But to help hold it in place, what I like to do, a bit of blue tack, get it roughly orientated, get the blue tack onto it, and then because that's pliable, we can use that just to move it into the exact location that we need it. And also leave the wire long like that. We can cut it after we get it on there. If you try to cut a section of wire, 10 millimeters long or something, you're never going to be able to control it to stick it down. Or, well, I couldn't anyway. So, flux up the area. I've just tinned up the iron, and then we're just effectively going to drag over the top of it. And that should be enough to get it stuck down. And just tin up those other traces while we're here, actually, since they're covered in flux anyway. Yeah, that hasn't really worked, has it? The wire is floating. I didn't realise. Yeah, I think that's us now. So just let me test continuity then from that pad up to the CPU. Yeah, and we're back. And just with a knife, I'm just going to nip that off. Quite hard to get into that side of it there. Let's just test the continuity again. Yeah, we're good. Tidy that up with a bit of IPA. There really is no need actually to put the nail polish over it, but I think I will anyway. You know, the copper will be okay now that it has the solder on top of it. But we'll just drop a little bit of clear nail polish over it anyway. Right, let's test it. Just do a quick power on test first, and then we'll try the cartridge. Hopefully that annoying keyboard error is gone, or well, the text, you know, typing itself along the screen. Oh yes. Oh yes, this is looking good. Cartridge. Well, we just go for the full diagnostic test. That was in dead test mode. I've just swapped that over. Quietly optimistic though. Come on. Out to the cartridge. And it did! You dirty swine! There was that broken trace all along. Right, come on. Let's get a clean bill of health. Unfortunately, I think I see a problem here. Those two timers on the bottom right hand corner there, they are not counting up. Why are they not counting? U7 bad? What? And U2, well, that's U2, the other CIA. Cassette bad? That might just be a dirty port, you know. I'll give those edge connectors a clean. But U7, 6510, the CPU is bad. And there was no sound. I tested that SID chip in the other board, and there was definitely sound coming out of that. Progress though. We are making progress. Can't understand why there's no sound. Well, that's why there's no sound. Because there's no 9 volt. Would that explain why we're getting the error on the cassette port? Because there's meant to be 9 volt of that as well, which runs the tape deck. But if that voltage was missing, would the diagnostic cart, well, does that check for the voltage? Or when it's doing its cassette port test, maybe it needs that 9 volt to be able to do that. And while it's not checking for the voltage per se, it's assuming, because it can't run its test, that there's a fault in the CPU and that CIA, both of which control the cassette port. But why is there no 9 volt? Hold on a minute here. The fuse is blown. That's an easy fix. Yep, the fuse is definitely blown. We'll just borrow the fuse out of this other machine for now. I suppose the question is, why is the fuse blown? But we'll take our chances. Put this back to voltage. Well, it didn't explode. Let's see if we have our VDD. And we do. Pretty much bang on 9 volts. But is that going to solve our problem? Well, you can see straight away there that the timers are counting. Why would the lack of 9 volt, the lack of VDD, why would that have affected those counters or those timers? Because the two CIAs do not run off the 9 volt. The only chips in here that have 9 volt are the SID. In fact, is it just the SID? I think the VIC. Oh, and the sound's working. Yeah, I was just saying, I think the VIC in the shortboard here just runs off 5 volt only. Outstanding. Clean bill of health for our Commodore 64. Well, there we are. That's it all back together. Commodore C64C is up and running. All it was in the end was the colour RAM and that broken trace. Nothing wrong with the CIA or the kernel or anything else in there. Bit of a shame that I didn't pay closer attention to that corrosion when I first looked at it, but there we are. It did send me on a bit of a wild goose chase around the board looking for a fault that wasn't there. It was just that damaged trace all along. But it's fixed now, so let's make it do something. I have the SD to IEC connected. And what will we do? Let's listen to something with a classic SID tune. How about Last Ninja 3? I absolutely love this intro track. Really just shows off what that SID chip can do. But this little machine, anyway, well, yes, it still needs a bit of a clean. So I'll do all that. This video is long enough without you watching me washing something. Needs a new badge there, so I'll have to order one of those. But while I'm at it, I did have to borrow some bits out of the other C64C, so I'll have to get a colour RAM and a fuse to put back into them to get that one up and running again. But that is it for this video. So hopefully you enjoyed what you've seen. If you did, I would appreciate a big thumbs up. Why not hit subscribe if you haven't done so already. Still plenty more yet to come here on CRG, and I'll see you next time.